All right, today we're going to talk about a really cool tool in the world of AI called Saliency Maps. And we're going to ask a pretty fundamental question. Can these maps really show us what an AI is thinking?
So we've got these AI systems that are, incredibly powerful. They can do things better than humans, from finding diseases on scans to driving our cars. But there's this huge catch. A lot of the time, we have no idea how they're making their decisions. It's like a black box, right? And that makes it really hard to trust them or to fix them when they mess up.
So the big question is, how do we get a peek inside that box? Well, for AI that works with images, one of the most popular ideas has been to create a kind of visual explanation, a way to see what the model is doing.
And that solution is called a saliency map. Honestly, you could just think of it like a heat map that gets laid on top of an image. The bright, hot spots, those are the pixels the AI decided were the most important for whatever decision it just made. The whole point is to give us a picture of what the machine is looking at.
And you know what? When they work, they look fantastic. I mean, look at this example. The model correctly identified a train. And the saliency map, it highlights the train tracks as the key feature. That makes total sense to us. It feels intuitive, and it makes you think, okay, this AI is reasoning in a way I can understand.
So, based on examples just like that one, the promise of these maps seemed enormous. People thought they could help us debug our models, figure out if an AI only recognizes a dog when it's on grass, and most importantly, build up our trust in these super complex systems.
It all looks really good on paper. But what happens when you take these supposedly helpful maps and put them in front of actual human beings? Do they really make the AI's thinking any clearer for us?
Well, a group of researchers at University College London decided to put that to the test. They set up an experiment to see if saliency maps could really help people get inside the AI's head and maybe even predict what it would do next.
So here's how it worked. People were shown images that an AI had already classified, some right, some wrong. Their job was to guess if the AI would get the next image right. Now, half of the participants got to see the saliency maps for help, and the other half got nothing.
So, the results? The group that had the saliency maps, the ones with the supposed explanation, they were able to correctly predict the AI's decision about 61% of the time. I mean, that's better than a coin flip, but it's not exactly a game changer.
But here's the real kicker. What about the group with no maps at all? They were correct 55% of the time. That means this powerful explanation tool only gave people a tiny 5.6 percentage point boost. It barely helped.
The researchers really summed it up perfectly themselves. They said the maps provided very limited help. So even though they might look convincing at first glance, in reality, they didn't really give people the tools to understand or anticipate the AI's behavior.
But the problem actually goes way deeper than the maps just being a bit unhelpful. It turns out there might be a fundamental flaw in how we even measure if a saliency map is any good in the first place. Take a look at this table. Researchers were testing different map-making methods, but I want you to focus on that top row, fake cam. This is essentially a completely uninformed, basically random map. And yet, on some key metrics that are supposed to measure how accurate they are, it performs surprisingly well. It's not that far behind the really sophisticated methods.
And this just brilliantly highlights the problem, doesn't it? If our own evaluation tools can be fooled by a totally nonsensical map, how can we be sure that the maps we think are good are actually telling us anything meaningful at all? It kind of suggests we might just be giving ourselves a false sense of security. And in fact, when you look at a lot of these saliency maps, they often don't look like that nice, clean train track picture we saw at the beginning. They look more like this. A noisy, speckled mess that doesn't really highlight anything that a person would call an important feature.
So what is going on here? Why is there such a massive disconnect between what these maps are showing us and what we humans actually find useful? Well, the answer might be in the word salience itself.
It seems there's a big mix-up between two different kinds of salience. On one hand, you've got physical salience. This is the machine's world. It's all about raw pixel data, contrast, brightness, color. It's what the computer sees. On the other hand, there's cognitive salience. That's how we find meaning, using our context, our memories, our culture. Saliency maps show us the machine's world of physical patterns, but we can't help trying to interpret them through our own human cognitive lens, and they just don't match up. Okay, so let's try to pull all this together. After looking at the human studies, the flawed technical tests, and the underlying theory, what's the big takeaway from all this?
Here are the key things to remember.
First, saliency maps are a really interesting first attempt, but they are not a magic bullet for making AI explainable. Second, their actual usefulness to people can be really limited, and they might even give us a false sense of understanding. Third, the ways we evaluate these maps are pretty flawed and can't always tell a real explanation from a random one. And finally, and this is the big one, if we want truly explainable AI, we need to build systems that actually account for how humans think, not just for what pixels are mathematically important.
And this leaves us with a huge, critical question for the future. We're building AI to make life-or-death decisions in medicine, in transportation, all over the place. So, if the explanations these systems give us are based on a logic that is fundamentally alien to our own, a logic we can't reliably interpret or predict, what does it really mean to trust them?